have multiple adapters that connect into a single IP address. And so the only way I can really make this work is to override the switch failover order and move the other adapter down into unused adapters. I need to do this here for storage 2, and I need to do it again here for storage 1. Click Edit, go back to NIC teaming, override the switch failover order, and then move NIC 2 down into unused adapters. If I click the OK button here, you'll notice I have an error message that warns me that this is currently bound to an iSCSI initiator, and I'm okay with that. We'll unbind it and rebind it later. But not much really changes here. The way that this screen looks hasn't evolved much, but what I have done is create a complete one-to-one linkage between storage 2 as a VM kernel port and specifically the physical adapter VMNIC2. I've done the same thing here for the original VM kernel port and VMNIC1. The last step that's required is back here under storage adapters and then back to the iSCSI software adapter, because I need to adjust the network configuration here for how I've bound these different VM kernel ports in the last step to the iSCSI initiator itself. Let me go back here and click Add, and you can see that I have both VMK1, the storage port group, and then VMK2, the storage 2 port group, that are available to me for binding to this VM kernel network. If I click OK here and I click OK again, I have now bound both of these two storage ports to the iSCSI initiator for the purposes of running iSCSI traffic across this connection. If I click Close here and then rescan the adapter and then click Properties, you'll notice that I have the ability to actually take a look at the path information for the connection of this iSCSI software adapter all the way back to its storage. Notice here that I have two connected targets, one device, and now two complete independent paths to those targets. Let's click Properties again and view network configuration. And you can see that my path status here is active for both of these two ports. I now have successfully created a failover capable and load balanced connection between my iSCSI storage and my server. This is a good thing. The last thing I want you to take a look at here is once we have all of this path information set up, I can go back to my storage here and take a look at the data stores that I was working with before. Now remember, I have multiple paths now to this data store. This is a good thing. I have two total paths, none of which are broken. But there is a chance here for me to manage the paths by clicking Manage Paths, and also the path policy associated with those two paths. There are, by default, a fixed path policy that's set for this connection. But what I may want to use is instead the round-robin path policy for enabling true load balancing across both of these two connections. Enabling round-robin is necessary if I want load balancing because the fixed path policy will only send data down the currently active path. Setting round-robin here, clicking Close and clicking Close again, completes the process of setting up a load-balanced and failover-capable path configuration for iSCSI. Now what have we talked about in this nugget? What we've done is really completed the whole storage conversation as it relates to VMFS data stores. We talked about VMFS and NFS data store properties and how they're somewhat different than the NTFS data stores and volumes that you've been working with in the Windows world. And we also talked a little bit about some of the use cases for creating multiple VMFS and NFS data stores. We had the opportunity to work with some data stores, not only creating them, but managing them, and including some of the new capabilities like user-defined storage capabilities and storage I/O control. We extended that VMFS data store, and then we also